the reaction that determines how long humanity can last. It is happening right now, every second, everywhere on Earth. A chemical reaction so vast and quiet that most people never notice it, yet it decides how long modern civilization can exist. Human survival has always depended on chemistry. Fire, metal, medicine, and energy all came from reactions we learned to control. But one reaction now stands above all others, not because it fuels growth, but because it limits it. Once this reaction tips out of balance, recovery becomes nearly impossible. To understand why this matters today, we need to step back. Civilizations do not collapse from a single event. They erode through chemistry. Soil loses nutrients. Water accumulates toxins. Atmospheres trap heat. Each change is molecular before it is political. And chemistry never negotiates with belief. The first narrative beat begins with carbon. Carbon is life's backbone. It stores energy. It forms complex structures. It cycles between land, ocean, and air. For millions of years, this cycle stayed balanced. Slow release, slow capture. Stability emerged from patience. Then humans accelerated it. Fossil fuels unlocked ancient carbon. Burning released it rapidly into the atmosphere. What once took geological time now happens instantly. The chemistry did not resist. It responded. The second beat follows immediately. Carbon dioxide absorbs heat efficiently. That heat changes reaction rates everywhere. Oceans warm. Ice melts. Water holds less gas. Feedback loops emerge. Each reaction amplifies the next. The system moves faster than before. The third beat is more subtle. Carbon does not act alone. Nitrogen cycles shift. Oxygen solubility changes. Soil chemistry transforms. Biological systems strain to adapt. What looks like climate is actually chemistry losing equilibrium. From the outside, these changes feel abstract. Temperatures rise. Weather destabilizes. But beneath every symptom is reaction speed. Energy entering faster than it can leave. Molecules vibrating harder. Systems drifting from balance. This is where the story sharpens. Because this reaction is not just about environment. It is about limits. The point where chemistry no longer supports the structures humans rely on. And once crossed, there is no quick reversal. The reaction that determines how long humanity can last is already underway. The only question now is whether chemistry regains balance or continues accelerating until systems can no longer compensate. Once atmospheric chemistry begins to accelerate, nothing remains isolated. Heat alters solubility. Solubility changes oceans. Oceans regulate life. Every system is chemically linked. At first, the planet absorbs the excess. Oceans dissolve carbon dioxide efficiently. Forests pull carbon from air. Soils store organic matter. These buffers evolved to handle slow change. They were never designed for speed. This is where the tension starts to form. As oceans warm, their chemistry shifts. Carbon dioxide dissolves into water. It reacts to form carbonic acid. pH drops. Acidity rises. Marine chemistry begins to destabilize. Shell-forming organisms feel this immediately. Calcium carbonate becomes harder to maintain. Shells thin. Reefs weaken. Ecosystems lose structure. What looks like biology failing is chemistry becoming unfavorable. Life does not disappear. It relocates or simplifies. On land, soil chemistry follows a similar path. Higher temperatures accelerate decomposition. Organic matter breaks down faster. Nutrients release quickly, then vanish. Soils lose long-term fertility. Agricultural systems strain. Food security becomes chemical, not logistical. The atmosphere responds too. Warmer air holds more water vapor. Water vapor traps more heat. Reaction rates increase again. This is not a loop humans designed. It is one chemistry recognizes immediately. Positive feedback. Here is the early conflict made clear. The carbon reaction does not need to be extreme. It only needs to persist. Small imbalances repeated reshape systems permanently. Each year compound to last. Recovery windows shrink. What nobody expects is how delayed the consequences feel. Emissions stop today. Warming continues tomorrow. Oceans release stored heat slowly. Ice melts long after chemistry shifts. The reaction has inertia. Once moving, it resists reversal. This is why time becomes the enemy. Not politics, not technology. Chemistry. Every delay increases energy stored in the system. Every year adds momentum. And momentum is difficult to erase. The reaction is no longer theoretical. It is active. It is measurable. And it is approaching thresholds biology has never experienced. The next phase does not require catastrophe, only continuation. And that is what makes it dangerous. Once this reaction accelerates, balance becomes harder to recover because planetary chemistry has memory. Heat absorbed today reshapes reactions decades later. Nothing resets quickly at this scale. At first, natural systems absorb the change. Oceans pull carbon from the air. Forests lock it into wood and soil. Wetlands slow chemical release. These buffers evolve for gradual shifts. They were never meant to run at full capacity indefinitely. As carbon dioxide increases, ocean chemistry responds immediately. Gas dissolves into water. New bonds form. Carbonic acid appears. Hydrogen ions increase. pH slides downward. This change is subtle but relentless. Each fraction of a unit alters reaction favorability. Calcium-based chemistry suffers first. Shells become harder to form. Skeletons weaken. Reefs lose density. Entire food webs rely on these structures. When chemistry shifts, biology follows. Not by choice, by necessity. On land, warming accelerates chemical turnover. Microbes break down organic matter faster. Carbon returns to the atmosphere sooner. Soils lose long-term storage capacity. Fertility becomes temporary. Agriculture begins borrowing from the future. The atmosphere reacts in parallel. Warmer air holds more water vapor. Water vapor traps additional heat. Reaction rates increase across systems. This feedback does not require intention. It emerges automatically from physics. Chemistry amplifies itself. Here is where tension deepens. None of these reactions need to spike. They only need to persist. Small annual increases compound. Decades turn imbalance into new normal. Systems adapt, but with reduced complexity. The most unsettling part is delay. Even if emissions stopped instantly, reactions would continue. Stored heat would circulate. Oceans would release energy slowly. Ice would keep melting. Chemistry does not stop when behavior changes. It finishes what momentum began. This creates a dangerous illusion. The absence of immediate catastrophe feels like safety, but chemistry measures outcomes differently. It tracks accumulation, not headlines. And accumulation is already far ahead. The reaction is no longer approaching the system. It is inside it, quietly reshaping conditions life depends on. And once thresholds pass, chemistry does not negotiate return. This is where the conflict reaches its most dangerous form, because chemistry does not collapse systems evenly. It destabilizes the foundations first. As temperatures rise, reaction rates accelerate everywhere. Ice chemistry changes. Permafrost thaws. Ancient carbon locked for millennia becomes mobile again. Microbes awaken. They metabolize stored carbon rapidly. Methane escapes. A stronger heat-trapping molecule enters the system. The reaction intensifies itself. Oceans follow a similar path. Warming water stratifies. Surface layers trap heat. Deep circulation slows. Oxygen distribution shifts. Dead zones expand. Chemical gradients flatten. Life loses access to stable conditions. Ecosystems simplify under stress. This is not destruction. It is reorganization. Complex systems collapse into simpler ones. Fewer species, shorter food chains, lower resilience. Chemistry favors states that require less energy to maintain. Stability returns, but at a reduced level of complexity. Human systems mirror this pattern. Infrastructure designed for narrow temperature ranges fails more often. Materials fatigue faster. Energy demand spikes during extremes. Supply chains strain. Each failure traces back to chemical limits, materials, fuels, and environments behaving differently under new conditions. The buildup becomes undeniable here. Civilization depends on predictability, predictable seasons, predictable yields, predictable infrastructure performance. Chemistry is removing that predictability, not suddenly, gradually, system by system. The most dangerous aspect is that collapse does not announce itself. It looks like adaptation. People relocate, crops change, technology compensates. But each adaptation narrows options. Each fix consumes more energy. The system becomes brittle while appearing flexible. This is the paradox at the heart of the conflict. The reaction does not end humanity directly. It erodes margins until one shock exceeds remaining capacity. Then failure cascades faster than response. Chemistry has no intention, no morality, no preference for outcomes. It simply follows energy gradients. And those gradients are now steeper than human systems were built to handle. This is the moment before reckoning, when continuation still feels possible, but reversal already feels distant. The reaction has reshaped the board, and humanity is now playing by chemical rules it cannot ignore. The climax is not extinction, it is limitation. The reaction that determines how long humanity can last does not end life. It sets boundaries. It defines which systems can persist and which must simplify. Chemistry does not erase civilizations. It constrains them until complexity becomes too expensive to maintain. This is a final insight. Human survival is not threatened by a single reaction. It is threatened by accumulated imbalance. Energy entering faster than it leaves. Carbon cycling faster than ecosystems can absorb. Heat moving quicker than infrastructure can adapt. Chemistry always resolves imbalance. The question is how much structure survives a resolution. The resolution is not despair. It is agency. This reaction is not beyond influence. Its speed can be slowed. Its pressure can be reduced. Buffers can recover. Cycles can stabilize. But only if chemistry is treated as a system, not a side effect. Modern relevance makes this urgent. Technology alone cannot override reaction rates. Policy alone cannot reverse accumulated heat. Only alignment with chemistry changes outcomes, reducing inputs, restoring sinks, allowing time for balance to return. This reframes progress. Survival is not about endless growth. It is about staying within chemical limits. Complexity survives when energy flows remain manageable, when reactions complete instead of compounding, when margins are protected instead of spent. Humanity can last a very long time, but not by ignoring chemistry, only by respecting it, working with cycles instead of accelerating them, choosing endurance over extraction. The reaction that determines how long humanity can last is not hidden. It is measurable, it is active, and it responds to every decision made today. Sometimes the smallest shift in perspective becomes the beginning of a new future. The reaction